Varun, Vasant, Yash. So we are doing methods yielding secondary amines. Okay. First method was by reduction of secondary acid amides. Okay. So in secondary acid amides, what we do? We treat it with lithium aluminum hydride and we get secondary amine. So this is the first method which we have covered yesterday. Now next one is by reduction of isocyanides. Second is by reduction of isocyanides. Isocyanides are also known as carbyl amine. Okay. So isocyanides or carbyl amines. So when we reduce isocyanides or we can say carbyl amines, then this is CH3N and triple bond C. Okay, Basant, you can prepare for the exam then. Okay, you can watch it afterwards. So isocyanides or carbyl amines are converted into secondary amines. How do we convert it secondary amines? By treating with hydrogen in the presence of nickel or platinum or palladium, catalytic hydrogenation. Okay. So in catalytic hydrogenation, we get CH3, NH and CH3. What is the name of this compound? Or so if we have cyanide, we get primary amine, and if we have isocyanides, we will get secondary amine. Write the product in the second case. Write the product in second case. And what are the IUPAC names of both? Third method is by the reduction of para-nitroso dialkyl aniline. Okay, para-nitroso dialkyl aniline with strong alkali solution. Just tell me what are the products formed fast. Do it fast. यार जल्दी. What is the name, IUPAC name of first one? It is N-methyl. Yes, N-methyl methenamine, or we can say dimethylamine. Good evening, Ashish. Okay, from 5 pre-boards. Okay. In the second case, what is the product formed? Aneri, good evening. So we get C6H5 NH CH3. Okay, and methyl methenamine, good. It's okay, spelling mistake is there, but I could figure out. So in the second case, it is N-methyl benzenamine or methyl phenyl amine. Methyl phenyl amine, right? Very good, beta, but it is not NH2, okay, Ashish, it is NH. Now next is by the reduction of para-nitroso dialkyl aniline with strong alkali. Very good, Saad, good. So you know, aniline, when aniline is treated with alkyl halide, okay, so in alkyl halide, R is negative and X is negative and R is positive, okay. So when alkyl halide react with aniline, hydrogens are removed by alkyl group, and at the same time both the hydrogens are attached to X to be 2HX is removed, okay. So we get N dialkyl aniline. Now after getting this N dialkyl aniline, if we treat it with nitrous acid, means HONO, then nitroso group is attached at para position. Keep in mind, nitroso group is attached at para position. So what would we get? Para nitroso N dialkyl aniline. So this is the product formed. After forming this product, if we heat it with sodium hydroxide or potassium hydroxide, then we get pure secondary amine along with this product, para-nitroso sodium phenoxide or phenate. So we get secondary amine along with para-nitroso and what is this? Sodium phenate, or you can write sodium phenoxide, okay. So this is the product formed and we get the secondary amine, which is the desired product, okay. But this is not in the syllabus, okay. So keep in mind that this is for the competitive exam only, third part, okay. First and second are there, okay. Now fourth one. Fourth method is also not in the syllabus, but sometimes there may be question in competitive exams, okay. So that is Mannich reaction. So what is Mannich reaction actually? In this case, one ketone, okay, let us say simplest ketone we will take, okay, acetone. It react with formaldehyde, okay, it react with formaldehyde, okay. CH2 double bond O, HCHO, okay, along with primary amine. So what are the reactants? One ketone, then with formaldehyde and primary amine, and medium is acidic. Medium is acidic. So when they react, what would we get? We get CH3CO, CH2, CH2 and CH2 के बाद it is NHR. Means one H from here, one H from here and oxygen from here. So water is removed. Water is removed, and then on reduction with lithium aluminium hydride, what would we get? Yes, on reduction with lithium aluminum hydride, what is the product formed? And this is called managed base. Yes, tell me what are the products formed? Yes, what is the product formed? Yes. बोलो बेटा. First we treat acetone, means ketone, with formaldehyde, right, and primary amine. So कीटोन का क्या रिमूव हो गया? हाइड्रोजन बाय द रिमेनिंग ग्रुप CH2 लग गया. ठीक है, CH2 ये कहाँ से आया? फ्रॉम फॉर्मल्डिहाइड. ठीक है, और ये आ गया कहाँ से? फ्रॉम प्राइमरी अमीन. ठीक है, ओके. So this is one type of secondary amine. There is no need to write further reaction. This is only the secondary amine. If we reduce, then it becomes CHOH. Okay. So ultimately, see, this is CH3, C double bond O, CH2, CH2, N, H and R. Okay. So it is an alkyl, or okay, alpha and beta. So we get beta amino ketone. Okay. So this is one type of secondary amine. Here, if you see, this nitrogen is attached to 2 carbon atoms. Okay. Now tell me, how do we prepare tertiary amine? Tertiary amine. Oh. So method yielding tertiary amines. So first method is same as we have done earlier. यार पता नहीं क्या हो रहा है. ओके, मैं ये बोल रहा था इसमें, इस मेथड में आशीष, दैट सी दिस formaldehyde as oxygen, okay, and what about this hydrogen from this, means alpha hydrogen from ketone, okay, and one hydrogen from primary amine, okay. So they are removed in the form of water. So we get CH3, CO and CH2, which is attached to CH2, and this CH2 has two attachments. One, it is attached here, and other it is attached on this side. So we get this product, okay, beta amino ketone, which is called Mannich base. Okay. Now next is to prepare tertiary amines. Now to prepare tertiary amines, first let us have this compound CH3, C double bond O, and N, CH3, CH3, okay. So reduce it with lithium aluminum hydride. Reduction with lithium aluminum hydride. What is the product form? Tell me. And what is the name of these two compounds? Reactant as well as product, both. Write the name. Write the IUPAC name of both. And if you wish to write common name, I have no issue. Just write the IUPAC name as well as common name. Just fast. Write the IUPAC name and common name. Write the products and write their IUPAC names. N ethyl methanone. N ethyl ethanone. Okay. This is IUPAC name of which one? First one? Very good, Sahil. See, this is actually CH3, C double bond O and NHH. So what is this? NH2 means ethanamide, or simply write it as NH2. Okay. So this is ethanamide. Now two hydrogens of ethanamide are replaced by methyl. So it is N dimethyl ethanamide. Now on reduction we get CH3, CH2 and CH3, CH3. That is N, N dimethyl ethanamine. Ethanamine, not methanamine, Sahil. It should be ethanamine. Very good. Second one is N dimethyl benzamide. Okay, and when it is reduced, we get CH3, CH5, CH2 and CH3, CH3. Okay, Prahesh, it's okay. It is N, N dimethyl benzyl amine. Okay, but in that case we should have what we have, amide with bromine and KOH. So where is bromine? Where is KOH? There is a reduction, lithium aluminum hydride is there. So just CO is converted into CH2. Okay. Okay, after doing this, last one is Hoffman elimination reaction. For that I will share video. Okay, I will send you that video. It is very important. Just I will write few things about it. Hoffman elimination reaction. Say there are two types of elimination, Hoffman and Sedgef. In Sedgef elimination, we get more alkylated alkene. Say difference between Hoffman and Sedgef. In Hoffman elimination, we get more alkylated alkene, and in Sedgef we get more alkylated alkene, and in Hoffman we get least alkylated alkene. That is the basic difference. So what we do in this case, first of all we should have quaternary ammonium hydroxide. Okay, like if we have quaternary ammonium halide, like this, tetramethyl ammonium chloride. It is, sorry, tetraethyl ammonium chloride. Okay, now tetraethyl ammonium chloride, when it is treated with silver hydroxide, so AgCl is removed and we get tetraethyl ammonium hydroxide, and when it is heated, on heating, what we get? Sorry, it is tetraethyl. So we get C2H5 thrice and along with CH2, double bond CH2 and water. So we get ethene as the product. Okay, so we get tertiary amine, that is triethylamine, ethene and water. A glimpse about it only. I am not writing the complete mechanism, just a glimpse. See, we have C2H5, C2H5, C2H5 and CH2, CH2H. One H, it is removed by OH negative. OH negative ion will get this H plus. Okay, so water is removed here. H as a removed as positive. Okay, so in this way, see, this nitrogen is positive because it forms 4 bonds. So on heating, see, H and OH will give water. This is alpha carbon and this one is beta. So it is one type of beta elimination. CH2 double bond CH2 and last one is C2H5 thrice N. That's it. But keep in mind, if we have ethyl and propyl, okay, then even then we get ethene as the major product. We get ethene as the major product. Okay, that is the beauty of Hofmann elimination. Otherwise, in SETGEF, we get that alkene which is more alkylated. Okay, but in this case, we get the alkene which is less alkylated. Okay. Oh, all right. Then next is, let's do some practice, like to convert ethyl chloride into normal propyl amine. Yes, tell me the scheme. How do we convert ethyl chloride into normal propyl amine? Ethyl means we are doing conversion of ethyl chloride into normal propyl amine. Can you tell me what is the scheme, or how do we think that, how do we proceed? Yes, what we do, tell me. First of all, what do you see in the particular conversion? Conversion, sometime conversion is of 7 marks and sometime it is of 5 marks, but conversions are always there. Anybody? First thing we should notice, very good, Sahil, 1 carbon atom is increased. first thing that you should notice that one carbon atom is increased. Okay, so whenever there is a question in amine or halides, keep in mind to increase one carbon atom, how do we proceed? What we do? Means it is ascending of series. Very good, Saad. We should use KCN. So CH3, CH2, Cl on treatment with alcoholic KCN, we get CH3, CH2, Cl. Automatically one carbon atom is increased and KCl is removed. Very good. And now it is very easy because next is CH3, CH2, CH2, NH2. Means increase of, means hydrogens are added. So that means reduction takes place. So reduction can be catalytic reduction. Right? Easy hai or difficult? Yes. So to increase one carbon atom, keep in mind we should treat it with KCN, but provided it should be halide or convert it into halide, because KCN will react with halide only, alkyl halide. Okay. So let us do second question, that C6H5 CH2 Cl into C6H5 CH2 CH2 NH2. Tell me what we do. I think there is no difference between these two reactions. What we do? First of all, this part seems to be very difficult for the students, but it is the most easiest part of the organic. If you know some tips and tricks, like here one carbon atom is increased, so obviously first step is to react it with KCN, but to react it with KCN we should have alkyl halide. If this reactant is not halide, here it is halide only. If it is not halide, then what we do? We convert it into halide. Then just reduce it. That's it. Very good. Great. What are the names of these compounds? See, this is chloroethane. If you talk in terms of IUPAC name, chloroethane. This one is propane nitrile. IUPAC name is propane. Yes, we can use lithium aluminum hydride as well. This is propane nitrile or ethyl cyanide. When we use alkyl, then cyanide, carbon of the cyanide is not counted. If you use nitrile, then carbon is counted. Okay, it is propane nitrile and common name is ethyl cyanide. Okay, then it is, yes, 1, 2, 3. So it is propanamine. Okay, second one is chloro-phenyl methane or benzylamine. IUPAC name is chlorophenyl methane. Chlorophenyl methane and common name is benzylamine. Then it is phenyl ethane nitrile, phenyl ethane nitrile, and last one is 2-phenyl ethanamine. Okay. Now tell me, to descend the series what we do? For ascending we use KCN. Okay. So for descending what we do? Descending means to decrease carbon by 1. So question is, write structures and IUPAC names of the amide which gives propanamine by, just tell me, for descending the series to decrease carbon by 1, which method is used in amines? Very simple method. Tell me. Sahil, Saad, Ashish, Yash, Praharsh, Charitrya, Aneri, Harshil, Varun, Yash. Tell me, which method is used to descend the series, to decrease the carbon by 1? So to increase we use KCN, and to decrease oh bhaiya, Hoffman bromide degradation. Hoffman bromide reaction. Okay. Yes, Sahil, it is Hoffman. So tell me, which amide? Yes, that is decarboxylation, or sometime decarboxylation give this product in amine actually. So best way is Hoffman bromide degradation. Okay. So because that give amine, okay, from amide. Yes, very good. It is Hoffman bromide reaction, right? So tell me, which amide will give propanamine as the product? Propanamine is the product formed. So which amide will give this product on treatment with Br2 and NaOH? Name the amide. Which amide will give this product? By Hoffman bromide reaction. Obviously CO is removed, right? So CH3, CH2, CH2 will remain as such, NH2 remains as such, and in between them there is a CO group. Okay, that is removed. Very good, beta. Sahil, very good. It is butanamide. It should be beta butanamide. Rutvik, It should be butanamide. Very good, Charitre. Yes, yes. It is CH3, CH2, CH2. This part remains as such, NH2 part remains as such, and in between them there should be CO group. Okay. 4 NaOH are used, and we get finally this amine, primary amine, along with sodium carbonate, sodium bromide, and water. That's it. Okay. Now, second part, the amine produced by Hofmann degradation of benzamide. Yes, tell me. On Hofmann degradation of benzamide, which amine is produced by Hofmann degradation of benzamide? Benzamide I will write, okay. Wow, Sahil, very good beta, very good. This is benzamide. So obviously this CO is removed with Br2 and NaOH. So CO is removed, and this Charitre, very good, along with 2 NaBr, sodium carbonate, and water. So we get aniline. So benzamide Rutvik, you are from 11th standard, that's great, and you are doing this question. Great. Okay. One more question. Reaction of ethanolic ammonia with C2H5Cl with ethyl chloride. Very good, Rutvik. Piyush, Kartik, benzamide. Beta, benzamide was the reactant. Benzamide on Hofmann elimination, Hofmann bromide degradation will give aniline. Okay, what is the reaction? Write the reaction with ethanolic ammonia. C2H5 with ethanolic ammonia. Yes, tell me. Ethanolic ammonia with ethyl chloride. So what are the products formed? See, nothing is mentioned that ammonia is in excess or not. So what are the products formed? What are the possible products? Write all the possible products. Ethanamide, beta ji, we have ethyl chloride. So on treatment with ammonia, yes, what is the product formed? Yes, where is amide? How do it get ethenamide? Beta, first of all, ammonia will react with alkyl halide, okay, that is ethyl chloride. So we get C2H5 NH3 positive Cl negative, means the salt is formed first of all. Yes, ethenamine is formed. Very good, Rutvik. Yes, first this product is formed, then ammonia. In the presence of ammonia, we get C2H5 NH2 along with ammonium chloride. So after the formation of ethylamine, you know, it is not given that anything in excess or not. So ethylamine can further react with another molecule of ethyl chloride. If ammonia is in excess, then we can stop here. Dhairya, you can send your mobile. This is my mobile number. After the class, you can call me. Okay, I let you know. So in the second phase, it gives diethylamine, removal of HCl. Okay, then next molecule can be added. So we get triethylamine, and at the end one more ethyl chloride is added. Yes, Rutvik, I am teaching 11th as well. So this is quaternary ammonium halide. This is the limitation of this method, that we get mixture of amines which are difficult to separate along with salt, along with quaternary ammonium salt. We get primary amine, secondary amine, tertiary amine, as well as quaternary ammonium chloride. Mixture is formed and it is difficult to separate. That is the limitation, but there is no need to write the limitation because we have to write the chemical equation. Okay, so just write all this, that we can get ethylamine as the major product when ammonia is in excess. Okay, and if ethyl chloride is in excess, we get mixture. Case 1, case 2, you can write like this. This is case 1, case 2. Okay. Second, ammonolysis of benzyl chloride. Ammonolysis of benzyl chloride and reaction of amine so formed with 2 moles of methyl chloride, with 2 moles of methyl chloride. Yes. Ammonolysis of benzyl chloride with first ammonolize the benzyl chloride, okay, and then amine formed. Now this amine formed should treated with 2 moles of methyl chloride. So see, first of all we have benzyl chloride. So this is the benzyl chloride. Now this benzyl chloride we treated with ammonia. So on treatment with ammonia we get amine, okay, because there is the formation of amine, then reaction of this amine with 2 moles of methyl chloride. So you know, when methyl chloride treated with it, obviously there are 2 hydrogens, so 2 methyl chlorides can react. So we get C6H5 CH2 and CH3 CH3. Can you name it? Write the name of this compound. Obviously this you know, it is benzyl chloride or chlorophenyl methane, IUPAC name, and this is benzyl amine or phenyl methenamine. Yes, it is N dimethyl dimethyl and phenyl methenamine, okay. Like this is phenyl methenamine, and when these 2 hydrogens are replaced by methyl, it is called N dimethyl beta benzenamine or benzylamine. N dimethyl benzylamine. You can write it as, if you write its common name, then it is N dimethyl benzylamine, and if you write IUPAC name, this is the IUPAC name, okay. Done. Now some methods, let's talk about its basic nature of amines, but today we are running short of time. Already it is 8:50. So let's stop here today. But before signing off, let us write 2 reactions. That is the commercial methods of preparation of amines. That is also not given by the NCERT. Commercial methods. Okay, of preparation of amines. Eleventh at 6 o'clock. Saad is my I would say, okay, Ashish, Saad, all of them, no. So first from nitrobenzene. So you know, nitrobenzene, when it is treated with hydrogen not in the presence of nickel only, okay, or platinum, we use vanadium platinum catalyst commercially, okay, or sometimes we can use cupric oxide at 680 Kelvin. Then we get aniline as the product formed in good yield. Okay, this is actually known as vapor phase reduction. So from nitrobenzene to get aniline, background assistant, okay, Saad. Okay, next is from chlorobenzene. Joke apart, really you people are very honest. Say chlorobenzene, like when we have vapors of ammonia which are passed through the aqueous solution of mixture of chlorobenzene and cuprous oxide, okay, at 473 Kelvin and 60 atmosphere, then we get this method. You have to remember here. Along with cuprous chloride and water, okay. So we get aniline either by nitrobenzene or chlorobenzene, okay. So first one is by using, we have used that scrap iron and HCl as well. So that reduction is also valid in the commercial case. This nitrobenzene with Fe and HCl, when scrap iron and HCl is used, we get aniline. That is also valid commercial method for the preparation of amines, or this method can also be used, okay, when hydrogen in the presence of cupric oxide or vanadium platinum catalyst is used at 680 Kelvin. And second is from chlorobenzene, when vapors of ammonia is passed through the mixture of chlorobenzene and cuprous oxide. So we get cuprous chloride along with aniline, okay. So that's all for the day. Thank you very much. God bless you all. Happy learning. Jai Hind.